Yeah, okay. Good morning, everyone. My name is Yasufumi Ogawa, research engineer of NTT, one of the Japanese telecom company. So today, I'd like to talk about a tiny framework for deploying app containers of DPDK. So this is the agenda. So first, I'd like to talk to introduce SPP. It stands for Soft Patch Panel. And SPP provides connectivity similar to voice switches, but the mechanism is simple for getting high performance. SPP was originally developed for service function chain for VMs and now available for containers. SPP container is a tiny framework for deploying containers and running DPDK application on the containers. And then I would like to share about the use cases, and then talk to limitations and restrictions for using DPDK app containers. And finally, I talk about debugging. So this is an overview image of SPP. So SPP behaves as similar to patch panel. So patch panel is used for connecting server and with LAN cable between servers, and SPP uses DPDK for connecting the VMs. And SPP enables to change network paths between VMs and configure with patch panel like simple interfaces. So this is the basic design of SPP. So SPP is derived from DPDK's multi-process application of DPDK sample application. It means that SPP consists of primary process and secondary processes. So primary process is a resource manager, and it's managed the mempool and buffer other DPDK resources. And secondary process is a workers. So there are several types of secondary process in SPP. For example, SPP NFA is for direct packet forwarding, and SPP VF provides the SRI-like functionality. And SPP Mirror is providing for the tap as a service of OpenStack. And in SPP, there are several virtual ports supported. For example, Ring, or vhost, or PCAP, or so. So here is an example of patch panel-like interfaces. So in SPP, so you can manage the network resources by using patch panel-like interfaces. So this is an example. So first line means that create a vhost port from secondary process. And then after creating ports, you can connect them by patch command. So first argument of patch command is source port, and second one is destination port. And you can also confirm the configuration by using the graphically. So by using top command. So SPP's top command shows the network configuration in graphical ways, as you can see here. So thank you for Phil and Thomas and Hideyuki and all of contributors for SPP. So it is now one of the hosted projects on dpdk.org. And you can get the source code and documentation from here. So I hope you try it if you are interested. So however, documentation on dpdk.org is not including the latest developing features. So we have another site for the hosting for the latest topics here. So then let's move on to the SPP container. So SPP container is a tiny framework for deploying DPDK application containers and connect them by using SPP. And primary and secondary processes also containerized. So by containerizing DPDK applications, you can deploy DPDK-based NFV services while keeping host environment clean. So each of containers are connected via ports, for example, vhost or ring. So incoming packets through the SPP and then go to the left side of application, then go to the between the SPP via ring interface. So in general, containerizing DPDK application consists of two steps. So first, building a container image from Docker file, in which package installation and compile the application defined. And second, launching DPDK application with Docker run command by specifying Docker options. So, for launching Docker application, you need to specify Docker option and the name of binary, and then options for DPDK's EL and application itself. So first step is building a container image. So this is an example of Docker files and Docker command for building a container image of DPDK application. So roughly, they are separated in three parts. First one is installation packages by using apt-get command. And next one is compilation of, for application. So in this case, compiling for DPDK's application and also DPDK sample applications. And there are two compilation steps in here. And final one is activate environments on each of containers. So next step is to launch app containers. So in this case, its launch is LC4 with 2 vhost ports. So before running this command, you need to create a vhost port for the container. And this command line divided into two parts. So first one is for Docker, and remaining is DPDK's command and its options. So in this case, so you need to add the privileged option of Docker command for sharing sockets and huge pages between host and guest content. And you also need to file prefix option of DPDK to create the metadata file for this process. So the reason is because the metadata file should be unique on the host, and even if inside the container, you should assign the unique name. So here is an explanation of SPP container tools. So deploying DPDK container is not so difficult actually, but it might be complex to manage Docker files if you have several applications and it have multiple versions. So it's also become a burden for users to input such a long command line anytime building a container image or launching the application. And so SPP container tools is introduced to solve these issues. So there are two kinds of tools included in SPP container. First one is build tools for creating Docker images. And another one is app container for launching each of DPDK app container. So in app container, it's included for launching forward or SPP sales or PMD or so. So for build tools, it's expand the options for your target environment to Docker build command. So here is an example of running build tools. The option is not so much, and it is expanded to actual Docker build command, as you can see. So in Docker command, Docker file is specifying with F option, and the path of Docker file is expanded from options for build tool. And it's also decided to the name of container images from these options. And app tools is to expand option for Docker run command. So it's also very simple for app tool. This example is for else forward. There are a few options, but actual command is just complex, as you can see. So for launching else forward inside the container, so you should add the vhost port, and it is expanded from the option. So the option takes two numbers, so 1 and 2. So it means that it has two socket interfaces as temp stock file on host, and it's used to create a butler interface inside the container, and it is created by specifying with voidable option. So you can also create app container script for your application. So to do that, you need to define Docker file of your your application, and in the Docker file, you should specify the path of binary file of your application and the comparison steps. And then you should also create app containers for launching. So to understand how to create your app container, it is the best example for launching Hello World application of DPDK. So there are 3 points. So first one is you should pass of your binary files inside the container like this. And then you should assign the unique file prefix for metadata. It shouldn't overlap from each other on the host environment. And final one is options for your application. So for Hello World application, there is no options, but your application possibly have options, and you need to define them here. So other details of creating your app container is described in this section of our documentation. So please refer to here if you are interested. So then use case. So I think there are use cases for using containerized DPDK applications. But in this presentation, so I would like to explain 2 focusing use cases as telco. And first one is resource usage. And we have expected to use several kinds of NFV services and combine them as service function chain manner. And container is less dependent from hosts actually, but it can be launched lightweight and quick comparing with using VMs. And another one is high performance. So we can use the connect between containers for connecting between containers using vhost is one option. But some use cases, it's not insufficient for performance. So for the use cases, so if you use containers, you can use the shared memory. It means each of containers can be connected via shared memory, and its packet forwarding is zero copying. So for first use case, so here is a simple example for describing how many cores is required in actual use cases. This is a test for SPP's packet forwarding by using 2 NFV applications. So in this case, it's using packet gen and its folder. And it's just totally requires 7 cores for building such a kind of environment. It's not so much comparing with VMs, using VMs. And this is another use case for describing high performance. So here is a result of zero copy packet forwarding through several containers. So as described in here, so containers are connected via ring interface in series, and even if connecting 10 containers, it still keep 10 giga wire rate for 64-byte short packet. And it is because using shared memory between containers. And it is possible if this process implemented as secondary processes of a multi-process application. So by the way, there are some limitations for using containers and BART-IO user interfaces for container networking. For example, cannot work with huge array, or you cannot use no huge option or so. And in addition to limitations, there are some restrictions for using containerized DPDK application. So it works fine if using before DPDK version 18.02, but for after 18.05, it doesn't work for some use cases. For example, 2 or more secondary processes cannot be launched, or vhost network possibly doesn't work. And it doesn't work for 11.8 or the latest version. Yeah. So this is one of them. And it is not able to launch 2 or more secondary process containers from version 18.0. It's because of change of initialization of memseg files. So the name of memseg files is decided in the function secondary MSL create work. MSL means memseg list. And in this function, so it's tried to create a memseg file by using PID here. But from inside the container, so all of process ID is 1. It doesn't happen if it's running on host, but it's occurred inside the container. And one secondary process is okay. But for secondary process, it's also trying to use using PID1, and it's failed to creating a file because it's overlapped. So to avoid the error, so we need to assign without using PID. So I think it should be a unique ID of container. And so actually, roughly, I fixed the problem. And so I'd like to send a patch for DPDK version 18.11 or later. Yeah. And finally, I'd like to share how to debug containerized DPDK application in our SPP use case. So I'm using my own repository for developing source code of DPDK and SPP. And here is steps of debugging. And first, create the version of DPDK and SPP and put them on GitHub. And next, create a Docker image from this repository, and like this, by using our build tool. And actually, it takes a long time. And then debug using the container image and modify code, and finally put modified code and to the repository and repeat returning to second steps. But it takes a long time again. But so I think actually it is not smart way, and I need to improve for more efficient way. Yeah, this is a future task for me. Yeah. So that's all. Thank you. So any questions?
Yeah, I had a question.
Yeah.
Hi. So the DPDK drivers have a dependency on the Linux headers, and if you were to build a container using a specific version, this is from my experience and I may be missing something. So if you were to build a container using a specific set of headers, does that put a restriction on the container that it could only be run on a host which essentially runs the same Linux, how do I say this, which is compatible with the same Linux headers with which the container was built?
Sorry, you question is so about the
So say when you build the DPDK drivers, right, you need to specify the kernel headers you're using to build the drivers, right? So now say I use kernel drivers 4.12 or 4.13 or 4.15 or something like that. And now I have a container using those headers which have DPDK drivers embedded in them, right?
So you mean how to set up the drivers or libraries?
No. So once you have the container, is there a restriction on which host that container can run on, or can that container run on any host regardless of? So say I built my container using a 4.13 headers, and now my host is running like say 4.20 kernel. Will this container built on 4.13 run on a 4.20 host? Does that make sense?
So you mean that the basically host environment is shared between containers?
Correct.
Right?
Correct. But so the containers have an expectation from the host in terms of compatibility when it comes to the kernel internal calls, which are defined, so to say, in the kernel headers.
I see. So so not for VMs. So by using container, so there is a limitation. So because from container side, many of the resources on host cannot change, and we cannot use all of version or all of application on container if you change the host environment. Yeah.
Okay.
Yeah.
Thank you.
Yes, thank you.
Any other questions? Okay. Thank you.
Thank you.